Okay, this is going to be a chi-squared goodness of fit test. We're going to see if Jose's sales match what the previous owner said his sales were, right? So again, we're going to check this data to see if it fits that data. And by fitting, that just means how close it is. You know, it's got to be relatively close. So we're going to do it mathematically. We're going to go ahead and use the formula for chi-squared, which can be found right here. Let's open that bad boy up. Yes, yes. Go to a different window. Yes, yes. And there is the chi-squared statistic right there. That's it, right? Chi-squared equals the summation of the difference of the observed minus expected squared divided by expected, and that's for each one of these things. So let's get back to our data set. And so first thing is we're going to look at the difference. So I'm just going to, let's type it in here. Difference between the observed and the expected. So this is this. I'm going to call this one the expected row, because this is the one where we get the information from the previous owner. So this is the expected row, and this will be the observed row. In other words, the real sales. And give me a second here. So first things first is we're going to look at the difference between the two. Again, we're going by that formula thing. Hold on. So we simply go equals this one minus that one. And then we just drag it out. Let's make these big so you guys can see them. And then we're going to whoop all the way across. So there's the differences. Some are larger than others, right? So it looks like their big days are Friday and Saturday. Good restaurant business. Now, so there's the difference between the two. Now we got to square these things. Going by the formula, we simply go up here and we hit equals. Click the cell that you want squared, and then hit Shift 6 2. That's the way I square things. There's other ways to square things in Excel, but this is going to square all those values. Now the last thing is we're going to divide it by the expected value, divided by E. And so we pick that cell, go to the function bar, type in equals, and I want this 225 divided by, which is a / underneath the question mark, boom, by what the expected value was, which was the original one, right? It's that one. So that is our squared difference between the observed and expected divided by the expected. Okay, so let's get that a little bit bigger. And I certainly don't need it out to a million place values, so let's make that a little bit smaller. We'll just go to 2 place values. And then we go that. So there's all the differences squared divided by their expected values. Now we're going to go ahead and sum all those up. Went to the auto sum up there, click the auto sum, and it's asking me, what do you want to auto sum? And I'm going to say, no, not these. I want these auto summed up. Enter. So that is my chi-squared test statistic. So now we got to look that up in a table. And let me pull up a table. Hold on. There's a chi-square goodness fit calculations by hand Excel. That's the one I'm looking for. I'm looking for the distribution table. There it is right there. Boom. So here's one online. Here's one you can download. Let's just open up this bad boy. And let it pop up. Give me a second here. There it is. Okay, so this is us. So we got to look up the degrees of freedom. So who remembers degrees of freedom? What you do is you take the number of rows, and there's 2 rows, minus 1. Multiply by the number of columns, minus 1. So we got 2 rows minus 1 is 1. And we got 7 columns minus 1 is 6. So 1 times 6 is 6. So our degrees of freedom is 6. And our chi-squared is 4.45. Remember that. So we go to row 6, degrees of freedom 6. And we look where our 4.45 fits. So it doesn't fit anywhere over here, right? If you go to the right here, these are the chi-squared tests. They get bigger and bigger and bigger. So our 4.5 would be probably somewhere over here off screen. And how to check out what the p-value is, that's what these things up here are in the blue square, or the blue rectangle. These are your probability values. So if they get larger when you go to the left, and that means for our chi-squared of 4.45, the p-value is going to be giant, right? It's going to be somewhere around 0.5, which is not less than 0.05, which means they're not significantly different. So if you can't find a table, which nobody uses anymore, this is another miracle of Excel. Just pick a cell, any cell, go to the function bar. We want to make sure we're in statistical. Now go to the chi-squared, there it is right there, chi-squared distribution. We type in our chi-squared number, degrees of freedom, and it gives us the p-value of it, right? So our chi-squared is 4.45, and our degrees of freedom was 6. And it should give us back a probability value. And there it is right there. That's our p-value, which means that the probability that the null is true is roughly 62%. It's not less than 0.05, so we cannot reject the null. The null states that there's no difference between the expected value and the observed value, and we cannot reject that because that is not less than 0.05. So in other words, these two values here are close enough to be considered a good fit. So that's how it works. I hope this helps. MGZ out.